Hi, everyone. I'm John Fulton. Thank you very much for being here this morning. I appreciate the opportunity that CouchCon has granted me to be here and talk about how novices learn to code, or what I've learned teaching in a coding bootcamp. We'll get right to it. Please feel free as I go along if there are questions. I'm watching the YouTube chat feature. So if you have questions, please post them there, and I'm happy to respond to them. And I'll be hanging out in the Slack room after the talk if you have questions or want to discuss anything there. So. So often when I come to a conference and I choose a session and I'm sitting in the session, I go, well, what do I want to get out of this? Why am I really here? So questions that you might be able to answer after this are, do I have a friend who I want to help become a developer? Am I responsible for the onboarding of junior developers? Do I mentor new developers as a part of my job or as a part of what I want to do in my organization? Or do I want to give advice to somebody who I know who may want to become a developer or who I think should become a developer? And those are some of the questions that I want to try to ask as I go through and talk about what I've done as an instructor teaching new programmers. Who I am, I've been working for 35 plus years as a professional developer. I figure that anything that somebody's paying me to do full time, I'm a professional. And so I consider myself to be a professional developer, having done assembly language and machine language and COBOL, and most recently a lot of C# and .NET and a lot of things in between. I have an undergraduate degree and a couple of advanced degrees, a Master of Science in Computer Science and one in Computer Forensics, Information Security. I spent 10 years as an adjunct faculty member at Franklin University, teaching basically the entire undergraduate curriculum in computer science, all 10 courses for a little over 10 years. And for the past 3 years, I've been an adjunct I've been a coding bootcamp instructor at Tech Elevator. And so I've gone through 10 cohorts now, which is how we measure our program, our 3 cohorts a year. And I'm just about to start my 11th cohort on Monday, the day after tomorrow, doing it this time virtually, doing it online rather than doing it in person as we have in the past. Here's my required sales pitch. Tech Elevator is a full-time coding bootcamp. We offer a 14-week in-person program that takes people who are not programmers and prepares them for a full-time job as a developer, helping them not only learn what they need to do in terms of the technology of programming, but also learning the skills that they need to find that first job, the soft skills, the resume and LinkedIn and interviewing skills, giving them practice interviews and helping them find that first position. We're very proud of what we do. I'm very proud of what I do. And my talk this morning is really the result of my experience at Franklin University as an instructor, but also my experience at Tech Elevator, bringing people in who are not programmers and helping them find that first job as a developer. Going the wrong way. There you go. So these are things, what I want to talk about this morning are the things I think I've learned. This is entirely empirical. This is entirely experience-based. This is not research-based. This is not me conducting experiments to test these things. These are my observations in the course of doing this as a developer, doing this as an instructor over the course of the time that I've been doing it. So. There is lots of research that talks about how adults learn, how technical skills are acquired. I've dealt with a lot of students that are on the autism spectrum, so how students with special needs learn, and I've adapted some of my teaching to those students. I have lots of students who come through the program whose native language is not English. English is not their first language, and so I've tried very hard to adapt my teaching style to them also. But this really isn't about that. There's a lot written about that, and I encourage you, if you're interested in the subject, to delve into it more deeply. And also, while I think all of these points are important, I don't think all of these points are important equally for all students. So what do I think I've learned? Let me get the controversial stuff out of the way, at least one of the pieces of this. I believe everybody can learn to code. I'm a big believer in the democracy of coding, of getting people involved in understanding the technology that their lives are controlled by. But what I don't believe is that everybody should do this for a living. If you imagine what your least favorite job would be, my wife is a social worker, and I can't imagine anything worse than spending all day long every day talking to people about the challenges and problems that they face with getting access to resources, with navigating bureaucracy, with making sure the right services are available to them. Day after day, week after week, month after month. I can't imagine a worse job. She absolutely loves it. But if you imagine that worst possible job, that's what programming would be for some people. Because some people, as many of you who are programmers know, programming is about frustration. Programming is about doing exactly the same things and expecting different outcomes. Programming is about every day facing things that you should know how to do and realize that you don't know how to do and having to go figure them out. And for some people, that's the worst possible job they could imagine. And so while I think everybody is capable of writing code, of understanding code, of programming, not everybody is well suited for this as a career. And what we try to do at Tech Elevator is try to make sure that the people that we take into the program are vetted, not only in terms of problem solving skills and a little bit of algebra, but also their motivation for doing it. Is this something they're doing because they're fascinated by technology, that they get strong rewards for problem solving, for being able to reach a successful conclusion to a different problem that they might have approached several different ways? Or are they doing this just because they think they can earn more money? They can have a stable job. And so that's a part of our vetting process that we go through. And I think that's important to our success, is in terms of being in a position to be able to select the right candidates. Another thing that I think I've learned in the course of doing this for a while is that programmers learn by programming. And while attending conferences and reading books and looking at YouTube videos and other kinds of paths are useful and interesting, programmers learn by programming. Programmers develop skills by practicing those skills. And I think of students as needing to develop muscle memory for the coding and debugging and testing that they'll need to do day after day when they're actually a programmer. And as many of you as developers know, if you're using a set of development tools, let's pick on Visual Studio or Eclipse. You go into the menus and there are hundreds and hundreds of choices, and we all know that we generally only use a dozen or so of all of those choices in the normal course of doing things. And so knowing which of those choices to make and how to use them and getting used to using them over and over again. Also, the ability in programming to fail and then to correct from those failures, I believe is essential to learning and then to mastery. I tell students that they don't own a piece of code until they've broken it and fixed it. And so that ability to learn by programming, to actually develop those skills. Another thing I think I've learned as an instructor is that some things are harder to learn than others. I call them cliff events. For a number of years, I've been an adult Boy Scout leader. And so we're hiking along a trail and we come along and everything's fine. And then suddenly we kind of go, whoa, there's a cliff. And so it's kind of like that in students who are learning to code. They learn about variables and they're fine, and they learn about assigning. They learn about assigning value to a variable and they're fine, and they learn about expressions and maybe even if statements and they're fine. And then we talk about collection objects and talk about arrays and lists, and suddenly they're completely flummoxed. And so there's a lot of those kinds of things that sort of come up along the path of learning, especially for beginning developers. Collection objects, being able to call functions or methods and pass parameters, the whole classes and encapsulation and objects and putting things off into separate pieces of code and calling them and getting responses back. And then, of course, the whole idea of frameworks and inversion of control and having somebody else's code control when your code executes. All those tend to be difficult concepts for beginning programmers. And so we've structured our curriculum and in teaching them, we try to introduce them several times to provide for what I've come to think of soak time, time for an initial exposure, some opportunities to work with them, and then to revisit them in increasing complexity as time goes on, for the student to be able to master those concepts. And repetition is critical. Repetition is critical in terms of lecturing and presenting information. Repetition is critical in terms of exercises and working through and getting practice doing things. I've often heard people say, well, I told the students this and they obviously didn't hear me or they didn't remember. And saying something once, I've discovered as a classroom instructor, simply isn't enough. For things that are important, I've discovered about 3 times is the right number of times to make sure something's repeated. And then maybe students will pick up on that and be able to incorporate that into the things that they're doing. And if the classroom was distracting with people having laptops open and phones open and having whispered conversations in the back row, being at home is even more distracting. And so it's going to, as we go forward, I think the challenge that we face is that there's even more things that are distracting people in the environments that they find themselves in. And again, with exercises, we've discovered that having somebody do something 2 times or 3 times generally isn't enough. We end up doing the Karate Kid wax on, wax off example of, we'll do 20 repetitions of having people create variable names. We'll have 20 repetitions of people going through and doing, looking at expressions that are being evaluated or assignment statements or creating if else, ifs based on the problem that they're trying to solve, just to make sure that they have mastered those skills and incorporated those skills into their set of tools as they move forward. A thing that I've learned as an instructor, other than the fact that I need coffee from time to time, is that reviewing code is boring. As a person who writes code and likes code, I think reading code and looking at code is exciting and interesting, and in some ways kind of like a novel. And it's really often not possible to skip to the back of the book and figure who the murderer was in the murder mystery. You sort of have to dig through and figure out the details. But to students, reading code is boring. And so what I've discovered is that, as tempting as it might be to create a well-crafted example that I can put up in front of students and lead them through it and explain to them the subtleties and intricacies of the code, more interesting to them and more engaging and more involving is to actually live code in front of them. And better yet is to have them code along with me. And so we've tried to structure our new environment, our remote environment, so that students have a laptop screen in front of them and have a second screen, so they can have one screen up with me yammering on at them about one topic or another, and another screen available to them to be able to code along with me, to be able to get stuck, to ask questions, to be brave enough to raise their hand and say, "Hey, I'm stuck. I couldn't get that to work. I've got a red squiggly under this. Could you help me with that?" And so, trying to get them to be brave enough to say, "Hey, why don't you share your screen with the class and let's learn from the challenge that you faced." And so that's the path that we try to follow in terms of coding together rather than trying to just review and present code. I only know 6 German words. One of them is Schadenfreude. Students love to see failure. Students will consistently remember and remind me of times that I have sat in class and made a mistake and they've had to correct me. Times that I've tried to improvise something in class in terms of writing code and not be able to get it to work correctly, get stuck in front of a class. And while that may come as a blow to my ego, what I realize that it's a remarkable learning opportunity for the students, because as often as I tell them that programmers make mistakes, it's another thing to see it happen. And of course, you're going to remember this slide because of the spelling errors, because everybody loves to see failure. Everybody remembers failure. And students do remember the instances when things go wrong. It involves them and engages them, but most importantly, it reinforces the idea that programming is fraught with daily mistakes. And our job as programmers is to push ahead, to correct those mistakes, to figure out how to make things work, or a way to work around the mistakes, to work around the problems that we have, and still be able to solve the business or organizational problems. And to respond to my friend Gene's question, no, the errors weren't all intentional when you were sitting in class with me, Gene. I make mistakes all the time. All you have to do is ask my wife. So. And as I said, programmers get stuck. I get stuck as a programmer, programming in front of a class. Any of you who are programmers know that you get stuck all the time. In any single line of code, there's probably a dozen things that can go wrong. And staring at your own code is probably the worst way to find an error, but sometimes that's all we have. And it's easy to stare at a single line of code and not see a misspelling, to not see a miscapitalization, to not see a missing comma, a missing semicolon, a missing parentheses. And so that's what programmers do, is programmers get stuck and then have to get unstuck and move on. And one of the big differences between a program like ours, where we have people acting as guides and interpreters and coaches to our students going through the program, and somebody learning on their own, is the lack of that patient, experienced, knowledgeable help to help people get unstuck. That's the biggest frustration that I've heard from students who have come into our program, who have spent, some of them, as much as a year learning on their own. And there's plenty of things out there to help you learn to code. But spending time learning to code on your own, you're subject to this stuckness of not knowing what problems are important and what problems aren't important, to not know whether the thing that you're suffering from in terms of getting your program to work is it a syntax error? Is it a misunderstanding of the concept? Is it a misunderstanding of the problem that you're solving? Is something wrong with the tool? Is something wrong with the hardware? Is something wrong with some piece of system software that you're trying to make use of? Without that knowledge and experience of somebody to help you get unstuck, you simply don't know. And an important part of our roles as instructors within our program is just being available to the student and saying, hey, everybody gets stuck. Let's see what the problem is, and to guide them through the process of problem solving, not only to get them unstuck, but to help them understand the process that programmers go through when they are then off on their own or more on their own, to understand the process they need to go through to be able to do problem solving and be successful as programmers. Beyond the first 3 or 4 weeks of teaching a new programmer to program, after we've gone through and learned variables and assignment statements and expressions and conditional execution, if else if, switch case, after we've learned collection objects, after we've learned looping, after we've learned putting things into methods and being able to call methods and return results, roughly that takes us about 4 weeks to master with people who have not programmed before. Much of what we spend the rest of our 12 weeks of direct instruction doing is talking about where to put the code, about putting code in the right place. And Steve talked about this a lot in his session before mine here, in terms of dealing with technical debt, but putting code into classes, building the correct methods that encapsulate the work that's to be done, using frameworks, using design patterns, following the principles of object-oriented programming. And so we spend a lot of time with students talking about putting code in the right place and trying to convince them, as we almost always do by the end, that putting code in the right place is important. That if I have a television class, that everything about a television is together in that one place. And if I need to change something about my television, if I need to fix something about my television, if I need to enhance my television somehow, that I should be able to know that that's going to be associated with that television class. That's all going to be together in one place. And so a lot of what we do with beginning programmers beyond the very first few weeks is just talking about those ideas of object-oriented programming, about design patterns, about working in frameworks, to make sure that they understand that, yes, their code, it's one thing to write code and solve a problem. It's an entirely different matter to make sure the code is in the right place so that they can find it, so that somebody else can find it, so that when there's a problem in their code, that they can fix that code. And whether it's them doing it, as I tell my students, whether it's somebody else working on your code, or whether it's you in the future looking back on your code as somebody who looks at the code and says, "Who wrote this?" And then to go back in the history, and say, "Oh, I wrote this. I don't remember this at all. This was more than 2 weeks ago." It's important that code be in the right place. Programming is full of doubt. Programmers doubt themselves. Programmers doubt themselves all the time. I say programming is full of daunting and unpredictable roadblocks, and you don't know what the roadblocks are going to be until you encounter them. The reason that Agile and Scrum are such wonderful such wonderful tools for us to use in the software development environment is they take into account the idea that there will be roadblocks. People in stand-ups every morning are confronted with the question of, do you have any roadblocks? Because the expectation is that there will be roadblocks, and whether the roadblocks are, again, just like the beginning programmer, whether they're at a syntax error, a misunderstanding of a tool, a failure to understand the problem. I love Matt's comment. Who wrote this? And say, oh, I wrote this. And I've had that. I've had that experience. I've had that experience myself with my own code. But beginning programmers, especially because they're new to the field, because they question themselves, and you may question, frankly, how could I possibly take somebody who's not programmed before and in 12 weeks help them become a junior level developer? And so that by itself inspires doubt, inspires question. I did a recommendation phone call yesterday for one of my students. And I recall the circumstance where that student had, after the first week of class, had dropped out of the program, just said, I'm can't do this. And I went back to her the next day, the day after she had dropped out. I said, you certainly can leave the program. You're an adult. You get to make your own decisions. But could we talk about why? And she told me, well, everybody else understands all of this, and I'm the only person who's not understanding this. I'm the only person who keeps getting stuck. I'm the only person who keeps having problems getting my code to run. And I said, I understand that you feel that way. You're wrong, but I understand how you feel that way. When you look around you and the rest of the class, about half of the students in the class have no real prior programming experience. Many of them feel exactly the same way you do. I would encourage you to reach out to them and talk to them. If you want to leave the program, you can leave the program, and we can, at this point, we could refund almost all of your money to you. But you decided you wanted to do this, and this was not an easy decision for you. Let's think about this for at least another day. If you would, I would appreciate that. And she did, and she ended up staying in the program, and she ended up doing quite well. And as I said, I did a recommendation call for her yesterday with a consulting company that I think she's going to be working for. And so programmers doubt themselves, and especially junior developers doubt themselves. And giving them positive feedback on their problem-solving skills, giving them feedback on developing their intuition is important in the process of supporting them and helping them grow as developers. And imposter syndrome is real. Anybody who doesn't believe that, you're simply wrong, because everybody who does this, everybody that I know who does this, when they sit down to take on something they haven't done even in a few weeks, or even something they haven't done before, how can somebody be paying me to be a programmer? I can't even do X, and fill in X with whatever you'd want. And for as real as it is for you as developers, it is even more real for people who are learning this process and learning to be developers. Another thing I've learned as an instructor teaching students to program, it is extraordinarily difficult to get them to use the debugger. And my spelling error in my first bullet point there is not intentional, showing that yes, I do make mistakes that aren't intentional. What does the debugger say? I could print that on a card, and if I got a nickel for every time I used the card, I'd have much more money in the bank than I do now. When we work with students will come to us and describe the behavior that their program is exhibiting. And our response to them is supportive and positive, but we almost always include in that first response to them, when we're talking with them about their problem, is, well, what does the debugger say? When you ran the debugger against this, what did it tell you? And helping students learn that this isn't a black box, that this is, in some ways, I've come to think of most computer programs as simple organisms, then the debugger allows us to see basically an X-ray inside, to see what's happening inside of that organism, to see the flow of data, to see the choices that are getting made, to see the actions of the looping that's happening. And we continue to drive the student back to the debugger. And as Derek, one of my former students, had to make myself a reminder on the desktop reminding me that debugging is a thing. And it's really hard because students think about writing programs and running programs, and it's then very difficult for them often to make that transition to think about it as a running, again, almost a living thing that they can then look inside of. The analogy I make for students sometimes is that, if it's Christmas morning, would you rather sit under the tree? Would you rather sit under the tree and shake the box and try to figure out what's inside? Or would you like to have a little window so you could look inside and actually see what's inside the box? And that debugger really sort of gives us a window inside of that box to see what's happening. Programming is a creative activity. A lot of students who I go through and read the entrance interviews, the application that they give us, the notes that the in-person interviewer creates after they go through the in-person interview with the students before we admit them, talk about the opportunity to be creative, and that's one of the reasons that they choose to go into programming. And so, because it is a creative activity, it sometimes can be a difficult thing to teach, because we have to help students understand and abstract the problem that they're solving, which often isn't clear, which we can make fairly clear for them, but in the real settings, of course, are often more difficult to understand. We can give them opportunities to practice different types of problems. As an undergraduate, I got through calculus by buying one of those problem books and working every single different type of calculus problem there was to solve for a single and multivariate calculus, until I could recognize the problem type and say, oh, this is a problem just like having water running into a tank and running out of a tank at the same time. I know how to solve that kind of a problem. And so we can have our students practice solving different types of problems that might lend themselves to a loop, problems that might lend themselves to an if statement inside of a loop. But what we really need to do eventually, before we turn them loose on the world, is we need to help them develop that intuition about, given a certain type of a problem, how can they express it in terms that the computer can understand? That really is eventually what we're teaching. I describe actually computer programming as looking at something that resembles a high school algebra story problem and expressing it in a way that the computer can act on it. And we help students practice that kind of problem solving often enough that they can develop, and then probably most importantly, learn to trust that intuition about how to solve the problem. We do whiteboarding with students. We go in a room, and we even have a little deck of cards that we've developed, 52 cards that have relatively simple problems to solve on them, mostly problems from the first couple weeks of the program. And they'll take a card and they'll go to the board, and we'll have them write code, usually a dozen, 24 lines of code to solve the problem. And I can't tell you how many times I've sat with a student and they've gotten part of the way into the problem, and they've been, they ask questions to help make sure they understand the problem that's being solved and refined it. And they'll start writing code, and then they'll pick up an eraser to go erase what they've just written. And I say, wait a minute, why are you erasing that? And I go, well, this can't be right. And I go, yeah, that's exactly what you want to do. And they go, really? I didn't think that was right. And I go, well, you wrote it. So, there's some part of you that thought it was right, or you wouldn't have written it down. Yeah, but I didn't think it could possibly be right. And so Having them trust that intuition, having them, and even if it's wrong, right? To go down a path and say, I'm going to explore this path and see if this path can solve the problem. And if it doesn't work, then I'll back up and I'll try some other solution. But having them to be able to learn to trust that intuition is an important part of what students have to go through in the process of learning to program. Another controversial thing I'll say, or perhaps it isn't controversial. It isn't controversial for me anymore because I've been saying it for so long. But programming isn't computer science, and computer science isn't programming. There are elements of each in the other. I think it's very difficult to learn computer science without learning at least some programming. I think it's very difficult to be a good programmer without knowing at least a little bit of computer science. But they are not. The Venn diagram for them doesn't overlap by very much. I have an undergraduate and a graduate degree in computer science. I think, computer science is a rich, multifaceted discipline drawing on, human factors and mathematics and electrical engineering and a lot of other disciplines, and having disciplines of its own. But programming is a trade and a craft. And when I'm confronted with the question of how in the world can you teach somebody to be a computer programmer in 12 weeks, I tell them, the folks across the street from our location on Kinnear Road at the Plumbers and Pipe Fitters Union, that have a trade school, they teach people to be plumbers. They don't teach them fluid dynamics. They don't have to learn metallurgy. They learn the craft of the things that a plumber needs to do to be able to do a job as a plumber. My stepson Chris is a environmental engineer, and he does know fluid dynamics, and he did have to do metallurgy, and he did have to do all of these things for engineering. And as an engineer, he can tell you to mathematical precision about the workings of a water treatment plant. But the plumber who goes in and actually puts the piping in doesn't need to know those things. And so, programming is a craft. It's a trade. We've reduced it, we believe, to the things that are essential for the core competencies of being able to program, being able to solve problems in a program, being able to convert a problem in a business or institutional setting to something a computer can act on. Computer science, I've had a number of computer science undergraduates come through our program because they've learned computer science, but they didn't feel as if they learned to program. They didn't think they had the craft and trade and practice of programming. And, we're happy to have them in the program, although the vast majority of people coming into our program, I would say about half of them have no prior programming experience before they join us. So as an instructor of programming, as somebody teaching programming, I have to juggle. I have to be able to do three things at once. I have to teach the syntax of some programming language. And it's not that it doesn't matter what programming language it is. Oh, no, wait, it really doesn't matter what programming language it is. I tell my students my favorite programming language is whatever programming language somebody's paying me to write in. So if you gave me a couple of days to study up and gave me a couple of large whiteboards, I think I can still reproduce the proof that I did in graduate school that shows that every programming language, every general purpose programming language is functionally equivalent to every other general purpose programming language, based on the work of our old friend Alan Turing back in the 1930s. So it doesn't matter what the programming language is, but they have to learn the syntax of some language. And, there are some languages that are probably better as first languages than others. they have to learn the tool set that they're going to use. So whether it's Visual Studio Code, or whether it's Visual Studio, or whether it's Eclipse, or whether it's some other tool set, they're going to be using some tools to be able to do that. Thank goodness we're not reduced to Notepad and executing things in a browser anymore for JavaScript. We've come beyond that, but it kind of doesn't matter what the tool set is, but we need to teach a tool set also. The most important thing we have to teach, the most important things a student have to learn, is the ability to do problem solving. And I've talked about that, the ability to take something that looks like a high school algebra story problem and cast it in terms that a computer can operate on it. And we have to do, as instructors, we have to do all three of those things at once. And so we generally start out by doing something simple, and then building increasing complexity as we go forward in time. And often we try to do it relatively seamlessly to not show these sort of gaps between these pieces. What's syntax and what's tools and what's problem solving. We tend to introduce them. We tend to make it as most good jugglers do. We try to make it look easy as we move through the process. Programmers don't get jobs because they can program. I've met a lot of people who can program. We've interviewed a lot of people coming into our program who can already program. The challenge is we don't know how to hire programmers. No two organizations I'm familiar with actually hire programmers the same way, and nobody quite seem to know how to do it. Everybody wants to go through an interview process, which means the programmers have to end up talking about programming rather than doing programming. Almost everybody has somebody do some programming to get a programming job, even though some people don't. Surprisingly enough, we've had people hired out of our program who have just, in fact, talked their way through interviews and gotten jobs without ever having shown anyone any programming ability. And we hire programmers. We take programmers into a hiring process and push them up through a hiring process, largely because of their ability to talk about programming, not their ability to program. And so in our program, we help students learn to talk about programming. Even though sometimes they don't hear us, we start talking about it the very first week, and then go through the process of having them work with partners, of doing practice interviews, of doing mock technical interviews, because if they're going to get a job as a programmer, they need to be able to talk about programming. And once they're on the job, they will also need to talk about programming. They'll need to talk about it with their manager. They'll need to talk about it with other programmers. They'll need to talk about a watered down version of what they're doing with product owners, product managers. But they will need to talk about programming. And here I've brought you a problem without a solution, because I don't know how to tell you how to hire programmers. I was a programming manager at Huntington Banks a couple of lifetimes ago, and I had hire-fire responsibility for the programmers working under me. And I interviewed programmers, and I gave them exercises to work on, and I looked at code from exercises they've written. And sometimes I did very well, and sometimes I did very poorly. So I don't have a solution for this. I just have a problem. But what I've learned is that programmers can't get jobs just because they program. If they could, then the people who teach themselves at home would be much more successful in landing jobs. They do need resumes. They do need LinkedIn pages. They do need elevator pitches. They do need to network, and those are all things that we work with our students to make sure that they're successful being able to do that. And when all is said and done, when we get to the end of the day, everything else can be forgiven when I'm teaching students, except for two things. The feedback that I get from students consistently, when they tell me I'm a good instructor, and sometimes they do, they say that the two most important things to them are the respect that I show them, If you're helping somebody else learn to code, don't make fun of them. Don't make jokes at their expense. Make jokes at your expense. Be respectful of them. Try to remember back when you didn't know how to program and you were learning to program, and embrace that experience and try to remember that experience and be supportive of them as you're going through the process. And then a passion for helping them succeed and be successful to the best of their ability. Some people learn this more slowly than others. Some people master it very quickly. Some people work through it at a much slower pace. And frankly, our vetting and qualification process sort of assures me that the students who are placed in front of me actually can do this work. But remember that not everybody who can do the work really wants to do the work. And so my passion and desire to see the students succeed, I can't want it more than they do. And so I need to be respectful of them, but I also need to make sure that I'm not trying to foist my agenda on them in terms of being successful as a developer. To be supportive of them, to be positive, to be reassuring. Patience is a very good virtue to have as an instructor in this field, and it's lots of people can do this, but it does take time and effort and patience to be able to help them do those things. I'm going to be finishing after this slide, but if you have questions for me, please add them to the chat in the YouTube channel, and I'll be happy to respond to any of those. We've got a couple of minutes left for questions. So in summary, this isn't for everyone. Everyone can code, but not everybody should do it for a living. Programmers learn by doing. If you're going to help somebody learn to code, find opportunities for them to code, find exercises for them, try to lay out a path for them to follow. There's lots of places to go. I'm very fond of the W3 Schools tutorials for different programming languages. And again, there are lots of resources out there. Lots of them are well structured. Programming is a creative and intuitive process. That's a difficult thing for beginning programmers to trust and understand. So being able to provide positive feedback for them, for their creativity, their solution to a problem may not be your solution to a problem. I've had to learn as an instructor to step back and not impose my design on other students, to not impose my prejudices about how to solve a problem on other students and allow them to be creative, and to support their intuition, to give positive support to their intuitive capabilities that they will need to develop. And again, being positive, providing positive and encouraging support as students are working through the process of doing this. And that's what I believe that I've learned in the process of teaching novices to be developers. My contact information is here. If anybody would like a copy of these slides, I'm happy to share. It's john@techelevator.com. Please feel free to reach out to me on LinkedIn if you'd like. And again, we have a online aptitude test for our program. If you know people who you think might be a good programmer, who are interested in programming, we're always interested in talking to people and helping them make good decisions about whether this is a field that they're interested in joining. Thank you for your time this morning, and let me look. Thank you for your kind words. I appreciate it. And again, I will be in the Slack room. CouchCon Slack room after this if you have questions. I'm also going to be listening to Matt's presentation. Matt Ealing is one of our Matt Eland. Matt Eland is one of our instructors at Tech Elevator and has the talk in the slot immediately after this. So thank you for your attention this morning, and I appreciate it.